Welcome to lesson number 6. We're going to be looking at the cosine law today. So consider this triangle ABC in which angle A is 36 degrees, AB is 3 centimeters, and AC is 6 centimeters. So what happens when we try to set up the sine law in order to determine the length of BC? All right, so I'm going to set up my sine law. So if this is side A, this is side B, and then this is side C, then A over sine A would be A over sine 36 degrees is equal to B, which is 6 centimeters over sine B, which is equal to C, which is 3 centimeters over sine C. Now, if we look at the ratio that we have, remember we need to know 3 out of 4 pieces of information. And I have 3 pieces of information, but there's no way I can connect any of these ratios in order to have 3 out of the 4 required pieces of information to solve for one unknown value. And so I can't actually use the sine law here. And so what we need to do is, think about how we can solve this example using a different process. Now in class example number 1, we're looking at this same triangle, but what's happened is we've added another triangle, which is a 90-degree triangle, which adds up, or which makes the whole thing a 90-degree triangle, a large triangle. Now, in this diagram below, we want to determine the length of BC, and we want to find that to the nearest tenth, just like we were doing up here. We want to find the length of BC. But we want to use SOHCAHTOA to do that. So first, what we will need to do in order to find this length here, and I'm just going to call it A again, we're going to have to first find the length of CD. All right, so to find CD, what we got to do is we have to use our sine ratio. And so if we think about this as one large triangle, I'll highlight what we're going to be doing there. So one large triangle, something like this, we're going to have to use our sine ratio. So sine of 36 degrees is equal to opposite over hypotenuse, right? We're using SOHCAHTOA here. So sine 36 is equal to opposite over hypotenuse, and the opposite side of this triangle, my big orange triangle, is 6 centimeters. Or sorry, that's my hypotenuse. And so I would have sine 36 and I'm going to call this x, is equal to x over 6. And so in order to solve for x, we just got to multiply both sides by 6. And so 6 sine 36 is equal to x, which equals and so if you're getting an answer like this, that means your calculator is in radians. You want to make sure it's in degrees. So 6 times sine 36 is 3.52. And I'm just going to store that answer for later. All right, now, so we have this value here, and now what we want to do is find the value from A to D. Now, from A to D, we have, from this point to this point, we can use our cosine ratio. So cosine 36 degrees is equal to AD over 6. And again, I'm going to go 6 cosine 36 is equal to 4.85. I'm going to store that answer as well, alpha B. Now, if I want to solve for BD, then what I can do is, and so what we did, we found this length here, and then we found the length from here to here. And what I want to do is I want to solve for BD. All right, so BD is going to be my length of AD minus AB. And then we can use our Pythagorean theorem to solve for this answer here. So length BD, so from here to here, is equal to AD, which is my 4.81, minus AB, which is 3. And we get an answer of 1.8541 with a few decimal places left over. Now, in order to solve for my length A, then what I'm going to do now is use my Pythagorean theorem. So using Pythagorean theorem, A squared plus B squared equals C squared. And we have this length here, which is my 1.8541 squared plus my 3.527. And that equals C squared. So I'm using all the decimal places here. So this answer squared plus my initial answer squared, we get 15.8753, 15.8753, and we got to take the square root of that. So square root both sides, and we get an answer of 3.98, and to the nearest 10, we'll round that to 4.0 centimeters. So there's a much easier and a much shorter way to do class example number 1, and that's by using the cosine law. Now in the cosine law, if we're looking for, side A, and that's what we were looking for, where this was B and this was C, then we would set up our cosine law like this. We would say that A squared is equal to B squared plus C squared minus 2BC cosine A. Now this is a formula that you'll be given, but that being said, you'll probably end up memorizing it anyways. But anyways, if I set up my cosine law, this is equal to B squared, which is 6 squared plus C squared, which is 3 squared, minus 2 times 6 times 3 times cosine 36. Now, it's when you first start, it's good to plug this in stages. So I would have 6 squared plus 3 squared, right? So if we do that in stages, we get 45. And then I would have subtract this next section. So we have 2 times 6 times 3 cosine 36. Subtract 29.12. So 29.12 with more decimal places. And so my A squared value, I would get 45 minus that answer, I get 15.8753. So 15.8753. Now that's A squared. So in order to get A, I need to take the square root of both sides of my equation. And so square root of 15 is 3.98. But to the nearest tenth, that's what the question was asking, we get 4 centimeters. And this ends up being way faster than our initial method for solving. Next, we're going to look at class example number 3. Find the length to the nearest tenth of a centimeter to the third side of triangle PQR if QP is equal to 1.7 centimeters, QR is equal to 3.1 centimeter, and angle PQR is 110 degrees. So we have 110 degrees here. This is side Q, this is side R, and this is side P. And we're told what all the other points are. So QP is equal to 1.7 centimeters. 1.7. QR is equal to 3.1. And we're looking for the third side, which is PR. All right, so this is the side we're looking for. This is our unknown Q. Now we want to set up our cosine law. So q squared, that's what we're solving for, is equal to r squared plus p squared minus 2 times r times p times the cosine of q. All right, so whatever angle we use is the angle that is paired with the unknown. So when we set this up, q squared is equal to 1.7 squared plus 3.1 squared minus 2 times 1.7 times 3.1 cosine 110 degrees. And q squared is equal to, so there's a way you can plug this in all at once. And notice how I'm gonna be starting this with double brackets, and then I close this set of brackets, and then I subtract another set of double brackets. So 2 times 1.7 times 3.1 cosine 110 degrees. Then I close that set of double brackets, and I get my answer of 16.104. So 16.1048. And I have all these decimals left over. But then I gotta take the square root of this. And I get my answer of 4 to the nearest centimeter. So Q is equal to 4.0 centimeters. Now looking at class example number 4, Bellevue is 30 kilometers north of Ayr, and Churchville is 18 kilometers northwest of Ayr. Calculate the distance between Bellevue and Churchville to the nearest kilometer. All right, so there's Churchville, and I'm gonna draw Bellevue up here, and then Ayr down here. So Bellevue is 30 kilometers north of Ayr. So there's 30 kilometers. And Churchville is 18 kilometers northwest. So northwest of Ayr. So that's 18 kilometers. And if it goes north and then west, if we think about this as a compass reading, so north, south, and then west, east. If we're going in this direction, then northwest, we could say that's 45 degrees. Okay, so that's 45 degrees, and that's what our triangle is going to look like. And we could label this too. That'd be A, this would be B, and this would be C. Now we're looking for the distance, the nearest kilometer from Bellevue to Churchville. And so we're looking for A, so A squared is equal to B squared plus C squared minus 2 times BC cosine A. And in order to solve for A, we're looking for, so 18 squared plus 30 squared minus 2, 18 times 30 cosine 45 degrees. A squared, let's see what we get here. We get my double brackets, 18 plus 30 minus 2 times 18 times 30 cosine 45. 460 is my A squared value, 460.32. And then I take the square root of that, and I get 21 kilometers. And that is my final answer.